All right, good afternoon, everyone. Thank you for joining us today for this webinar panel on agency readiness for predictive analytics. I just want to remind everyone before we get started, if you have any questions, please be sure to post them in the Q&A chat and we'll get to them at the end. This is a recorded webinar session, so we will be sending out the recording afterwards. And I would like to go ahead and introduce our moderator for today's event. We have Kathleen Walsh. She is the Principal Analyst at Cognilytica, as well as one of our analyst chairs for the ATARC AI and Data Analytics Working Group. Over to you, Kathleen.
Thanks so much, Kirsten, and I'm happy to be here and moderating this session today. I'm Kathleen Walsh. I'm a managing partner and principal analyst at Cognilytica. We're an AI-focused research, advisory, and education firm. And about half of our business is with the public sector and half of our business is with the private sector. So I'm excited to moderate this panel today. It's on agency readiness for predictive analytics. This panel is going to address how different government agencies should be addressing their level of where they are in their journey with predictive analytics. It's also going to discuss workforce requirements, how to succeed with predictive analytics projects, some examples of successful projects, and more. So as Kirsten mentioned, we will leave some time at the end for Q&A, so please do make sure to type in your questions into the chat as they come up. I know that everybody who participates in ATARC webinars always has a lot of questions, and so I love that. So I want to make sure that we have time at the end to answer that. But with us today, we have three great panelists, and so I will let each of them introduce themselves. And we're going to get started by having each panelist introduce themselves and also define how they define predictive analytics, and then maybe some different areas of predictive analytics. So Shakib, let's start with you.
Good afternoon, everyone. Thank you, ATARC, and thank you, Kirsten, and thank you, Kathleen, for moderating this panel. My name is Shakib Shraibi. I'm Chief Data Scientist at NTIS. NTIS is the National Technical Information Service. It's a federal agency within the US Department of Commerce. And we have this unique mission because we have data innovation as part of our mission. Our mission is to provide innovative data services to federal agencies to advance their federal data priorities, enable operational excellence, and achieve mission outcomes. Actually, we are currently assisting several federal agencies, harnessing data science, machine learning, artificial intelligence, blockchain, and other emerging and innovative technology to achieve mission outcomes and deliver data-driven solution within the NTIS framework. It includes DoD JAIC, DHS, DOL, the Department of Energy, HHS, and others. Let me talk about predictive analytics. I will put it in a very simple terms because I think it's very important to just know the basic capability of predictive analytics. Predictive analytics, I would put it as the use of data and statistic algorithm and machine learning techniques to identify the likelihood of future outcomes. So it's basically predicting future outcomes based on historical and current data. And you can use the different predictive data modeling techniques to analyze past data or to identify trends, and but also predict future outcomes and make informed business decisions. Today, predictive analytics extensively uses machine learning for data modeling due to its ability to accurately process vast amount of data and recognize patterns. So we've been, for instance, using predictive analytics, of course, in our collaboration with federal agencies in different areas. It's either you're trying to optimize your resources. For instance, we can discuss later on, but let's take an example of predictive maintenance. In predictive maintenance, you want to try to detect if something is going to fail, or you're going to have a lack of resources in some places. So you want to be proactive and then either replace something that's going to fail preventively, or at least know how to optimize the resources that you have in order to mitigate that risk and ultimately even prevent it. So, but the most common use of predictive analytics that probably the audience is familiar with is of course forecasting. So you can use predictive analytics to forecast either a metric value, so that's what we call using a regression model, or you can use it in classification modeling, where you actually use predictive modeling to categorize a situation or an object or an image or a scan, a medical scan, and so on and so forth into whatever it's a positive or negative, for instance, for certain disease, and etc. So we will have a chance, hopefully, to talk more about the different application of predictive analytics. But again, to make it short, it's predictive analytics models are designed to assess historical data, discover patterns, observe trend, and use that information to draw up predictions about future trends.
Great, thank you so much for that introduction and your definition and examples. Michael, let's go with you next.
Yeah, thank you, Kathleen, for having me on this panel today. My name is Michael Collins. I'm a statistician in the Enterprise Data Directorate at the Office of Federal Student Aid. We're an agency of the U.S. Department of Education. You've probably heard a little bit about some of our programs in the news lately. It was certainly a topic of discussion leading up to the recent election. So we're the primary agency that the federal government uses to disperse grants and loans for higher education to individuals. We use predictive analytics in a variety of places for our enterprise. And just to riff on what Shakib was talking about, so we'll use it to predict outcomes, but we'll also use it, sort of for policy analytics as well, to say, well, what are the effects of a change in policy? Who does that impact? How does that impact our business? Because we're both a business and a government agency. So we'll evaluate some of those things in terms of helping to make policy formulation, and also just general predictive issues. There are questions about, well, how big is our loan portfolio and when is it going to reach XYZ number, $2 trillion, say? So, forecasting is something that we do quite a bit of, but we also use other types of predictive analytics techniques for processes in our business that used to be done in a more heuristic manner or in a more ad hoc manner. So we're really trying to move along in our journey as an organization to use some of these techniques to improve the performance of our business.
Great, thank you. And Malio, let's have you introduce yourself next.
I'm Dr. Malio West. I'm the CEO of Global Accounting. We have over 118 employees through Portugal, here in DC, also in Portland, Oregon. We help do predictive analytics for the financial institutions, a lot of the inventory control, and we also use it for timing and things like that. So to kind of piggyback off of what Michael and Shakib said, I want to thank Kristen for inviting us and Kathleen for moderating. Predictive analytics is machine learning, whether it's linear or nonlinear models, or deep learning, whether it's pictures, text, messages, and things like that. So there's a lot of ways to use predictive analytics and outcomes, and there's different algorithms to set up a model.
Alrighty, great. Well, thank you everybody for introductions and a very brief definition of what you define predictive analytics as. Now I want to start getting into the meat of things. All of us are on the predictive analytics working group at ATARC, so plug in for anybody that's listening in on this webinar. If you're not already a part of that group, please reach out to Kirsten, because we're always looking for more members and would love to have you. The Predictive Analytics Working Group is currently working on a white paper where we're going to help frame some areas of predictive analytics that we've identified in the group, and then we plan to dig deeper into some of these areas of application. So can you provide some examples of projects that you've successfully used predictive analytics on in a government setting? I know we addressed it, just a little bit in your introductions. So I'd love to go into more detail, especially maybe about forecasting. So Shakib, let's start with you.
Sure. Yeah, let me talk about a few projects that we've been working on and that we're still working on. So for instance, I mentioned HHS, so we work also with the VA. So we're working actually with the HHS OIG and the VA OIG, Office of Inspector General. Both of these organizations, they want to make sure that every dollar spent is properly spent in an approved transaction. And they want, of course, to support better service outcomes at lower costs, so to optimize their operation as well. So we've been actually using AI and advanced data analytics to identify suspicious transaction by detecting anomalies and unusual patterns. And that resulted in identifying overpayment or improper payment or even fraudulent schemes. Actually, it would be interesting to look into some examples that were that we actually identified. If we, for instance, like we identified somebody that was actually cutting nails, and then have like categorized them as a surgical operation and charged Medicare for that. So the point there is that we look at the at trying to do anomaly detection, which is part of predictive analytics. So looking at patterns, and that's a very difficult area in predictive analytics. So you have to do it step by step. First, you have to collect the data that you need, and then you need to develop a system about how to detect anomalies, and that include subject matter experts that are there. So first step is to do some visualization, just to look at if there are some patterns that are out of whack, and then the second step is to augment the subject matter experts. So what we do is that we collect data, and we do the tedious work that normally subject matter expert has to do, which is like looking at data from here and then picking up data from there, including even like public data or social media data, and then or newspapers articles or something like this. All that can be actually harvested and aggregated to provide ideas of if there is some, of course, financial data, etc., to provide a background, and then the support for subject matter experts to actually they can focus on what they are specialized about, which is detecting fraud. So we did that with the HHS OIG, VA OIG. They were also able to save money, for instance, for when they provide help for VA veterans in paying the tuition for education and so on and so forth, because you have to look at fraud detection as more wholesome. You have to look at it in a wholesome view, because if you it's not just about like wasting money, it's that money that can be used to help others or to help you better, etc. So we did that. We worked also with DOL with the same thing for data collection, processing, and dissemination. So at DOL they had they have different units that work in different areas, and that's common thing in agencies that they have a stovepipe application, and they work well on their own. But if you want to have a global picture, that is very helpful if you want to do prediction and predictive analytics. You need to start integrating those stovepipe applications into one. So we are working on establishing a data infrastructure that will help them integrate all their data and help each unit to actually get a better understanding of what the data tells them, not just within their unit, but across the agency. So we have also made headways in processing errors, in claim processing, or authenticating and verifying the eligibility of claimants, and so on and so forth. In terms of predictive analytics, and I'll make it quick, maybe I'm taking too much time, but let me give you another example that is also close to, I think it's important for everyone to, especially in the context of COVID. We're working also with USAID in the President Malaria Initiative. And that's basically, the impact of that is literally saving lives. Malaria is a serious disease. In 2018, there was an estimated 228 million cases of malaria occurred worldwide, and about more than 400,000 people died, and mostly children. So we're working with the USA to collect data more efficiently and more effectively, literally from all over the world, and in different languages and different format. So you're talking about structured and unstructured data that coming in, and we're trying to efficiently integrate the data to support predictive analytics and provide complete and accurate information that will enable evidence-based decision for resource allocation and prevention. For malaria is caused by mosquitoes, and mosquitoes, they survive in a very special weather situation. So that's one thing that we do, is that we collect information about the weather, about different parameters that may affect the resurgence of malaria, but we also about populations and their movements, and then the resources that we have there. So we can actually do a good prediction about where the next malaria is gonna maybe burst, and then use the resources properly to prepare for that and mitigate the risks related to that.
Okay, great. Yeah, I mean, that's all about taking, historical data, like you said, and then applying it to current use cases. So that's great. Malio, you want to go next?
Be good if I turn my switch on. So we use we use 5 different type of data of analytics models. We use a classic model, which is predictive binary outcome, and we use it over in Spain because we're on a Spain IDIQ, and we help Spain understand their default rate in all of their loans, and help some of their call centers, and how the call centers are churn. They call them churns. How people go into the call centers and then they break off. We also look at we also use another one called forecasting modeling. And forecasting modeling is we do a lot with stock market. So we're on IDIQ in South Korea, and we use forecasting to help Samsung understand the 5G data analytics for pricing and pricing modeling. Say, for instance, if they build a tower, how long will that tower last? So when you're forecasting out a life cycle of a particular tower or particular data farm or something like that, you use the forecasting modeling for that. We also use something called anomaly modeling. Anomaly modeling is kind of what Shakib said. You see that there is a pattern of data, but you also see certain anomalies. So say, for instance, if there is fraud detection or claim fraudulent detection within, we use we have 2 commercial clients, and I'm on the board of director for AHIMA. And AHIMA is a health information management nonprofit. So they certify 80% of the healthcare industry in the United States for bill coding, cybersecurity, high trust, and things like that. So they look for fraud patterns in the bill coding area. So that's kind of modeling, that's anomaly modeling, like Shakib said. And we also have something called cluster modeling. Cluster modeling is segmented and targeting, and it helps with, since I'm on the board of directors for AHIMA, it's patients that have a better segregated, or how to take care of patients better. That's a clustering modeling. And there's also something called a time series modeling. And we're on a IDIQ with in Spain called rapid response, which means that we're forecasting sales in certain areas of the country, especially when it's affected by COVID. So if there's a big outbreak in COVID, the modeling is time series modeling helps predict out the season change in certain business cycles. So that's kind of where we're seeing the different type of modeling. It's classic, forecast, anomaly, cluster, and time series modeling for predictive analytics. And it affects whether it's machine learning or deep learning algorithms and things like that. The algorithms that we've been in contact with is called, like, say for instance, random forest modeling. That's a decision tree type of algorithm that before we set up the modeling, we have to understand that what's the algorithms we're going to use for different type of scenarios. So you have to understand the scenario that you have to pick the algorithm and the modeling for decision tree making or for linear regression analysis and things like that. So that's kind of what the things what predictive analytics do for in the financial institutions, the practical world for 5G, or any cluster of things as far as logistics and supply chain management and things like that. So that's kind of how predictive analytics is.
Great. And Michael, do you want to answer the question too?
Yeah. So unlike Malio and Shakib, we have a very specific focus on our particular business. We don't do really consulting, but we find that predictive analytics is used in a lot of different places, just in our own business. So a lot of these will sound very similar to the types of things that Shakib and Malio were talking about. So we'll do predict probability of loan default. And at a variety of places in the student aid life cycle. So we'll predict that when an applicant first files their FAFSA form and applies for aid. And we'll do it again at the point in time in which they actually are in college and they're getting their aid dispersed. And then we'll also model it again when they stop going to school, either have graduated or dropped out, and model the probability of default at that time. And of course, those sound like very similar problems, but we have very different types of data at those different points in time. So as an example, one of the most powerful predictors of whether or not a borrower will default on their loan is whether or not they finished their program and graduated. And we won't know that until they've either finished or not, until they've gone into repayment. So that's one example of a type of business process that we can use. And then we can use that probability of default from that model for a wide variety of things. So we can use it for forecasting what our cash flows are going to be. We can use it also for things like outreach. So we have models that we use for message testing and to tailor communications to our customers. So not everyone who newly defaults is the same. So we'll have some borrowers who just forgot, like, they have a 6-month grace period after they finish school to start repayment, and they just didn't do that. And that's clearly going to be a much different situation than someone who's been making payments for 5 years and then suddenly stops making payments. And we're trying to use predictive analytics now to detect and tailor messages before default. So someone starts getting late on their payments and they haven't defaulted yet. We want to help them stay out of default. And it may be that they just don't know about some of the programs that we have that can help them. So that's a really great application that we think helps Americans. And particularly right now, we're currently in a situation where all student loan payments have been suspended as part of the CARES Act. We're getting ready to go back into repayment on a lot of that, and we have messaging that's going out to all of our borrowers to let them know, hey, it's time to go back into repayment. You need to start making payments again. So looking at what are the results of those messages, whether people are clicking on the link in their email and opening it up. Those kinds of things are really powerful to both improve the performance of our portfolio, but also to just help our borrowers.
That's great. I think I was excited for this panel because everybody has such diverse backgrounds, and the examples that you provided were diverse as well. I know that for agencies who may be new on their journey, they look to use cases and other examples of how people and different agencies, different groups, organizations have done things, because it's a lot easier to start with some sort of roadmap or guidelines or, examples that they can at least point to. So for agencies that are new on their journey with artificial intelligence and predictive analytics, what tips can you share with them to help them get started on this journey? This can be, you can take this in a variety of different ways, maybe with data prep, data collection. What kind of team do you need to build? What kind of realistic expectations do you need to set with, how large of a project to take on, timelines, things like that? Malia, let's start with you.
One of the things I've seen that agencies should be kind of understanding is establishing a data governance process. We, Shakita and Michael and I, in our white paper, we talk about data governance, and data governance is everything. Also is big data sets. How are you going to disperse, or what algorithms you're going to use for your big data sets, whether it's IoT, which is, they call it a fire hose, pretty much, or if it's in the cloud, or things like that. Because a lot of agencies I've seen, they still have mainframes, and going from a legacy system to a new system, the clustering of data, they don't always talk together. You have to consider the AI technology, whether it's machine learning, computer visualization. You also have to understand the training of users in the predictive analytics. That's one of the things I've seen that agencies need to look at. But there's also some risk. You have to have a lack of adequate skill set in the government, and you have to consider the data privacy. You also have to understand the complexity and accessibility of the data, because algorithms sometimes can be biased if you're programming right or wrong. So those things like that, I would say that what the government should also look for, and some of the skill sets you have to look for, and when you're trying to retrain or rebrand or bring on new staff, looking for those processes, those governance, the privacy ethics and things like that, what I've understood.
Great. Shakib, what tips do you have?
I think Manuel made a great point about the data governance. We know that predictive analytics is rooted in data. So data is critical to any application of predictive analytics you want to do. And so whenever we at NTIS, we have a unique perspective because we're working with so many different federal agencies on so many different use cases. And then we have this perspective of trying to find what are the lesson learned from each, and then what we do usually when we work with an agency is we focus on the mission. We try to understand what is the mission of the agency, what are the mission outcomes that they're trying to accomplish, because that's critical before even trying to see, okay, should we use AI or not? Let's see what we want to solve. What's the problem? Because machine learning and predictive analytics is just about making the agency achieve mission in a more optimal way, in a more effective way, in a more efficient way. So we focus on pain points. You say, what are the pain points? What you're trying to solve? And when an agency also asks, when should we start? And reiterating Malio's point is that start right away, at least dealing with the data, because data is key. So set up the data governance policies, enrich your data, start collecting the data, see or how you can integrate your data. So you have to look at it from three aspects: from the technical, from the organizational, and the operational point of view. All of those three have to come together. So what we've seen is that we have seen that agencies have implemented simple AI-based applications such as automation or developing some specific visualization application or dashboard and so on and so forth, or even experimenting with simple machine learning model. And we have worked also with agencies that are really in the cutting edge of AI, doing real-time intrusion and detection in cybersecurity, or trying to recognize objects in the video data, or performing predictive maintenance. The problem is always in the middle of the adoption spectrum. So as I mentioned, while use cases and challenges may differ, the underlying requirements are fundamentally similar. And so you need the maturity of your data architecture, the capability to support your data supply chain, and the leadership engagement and the data culture to drive the AI game-changing methodology and solutions. And like Mario said, also the workforce to support that. Usually what and each organization, and they don't have to use the same model because it depends on their mission, their size, their funding, etc. But common, again, the common requirements are going to be, the fundamental requirements are going to be the same. It's all about like trying to solve the problem, put it in if you want to solve it with AI, which is very efficient and effective, you have to put it in a data terminology form. Is it a fraud detection problem? Is it a forecasting problem? Is it an optimization problem, and so on and so forth? So, and that help you, or a combination of those, but that help you try to find where the data that you need. And then if you have the infrastructure, a modern infrastructure that allow you to not only acquire or capture the data, and then if you have the workforce to prepare the data and clean it and make it ready so you can actually be able to run your predictive models to actually predict the possible outcome for your problem.
Great. And Michael, what advice do you have?
So I'm going to probably take this in a somewhat different direction. And I think it has to do with the fact that I'm in-house as opposed to being a consultant like Shakib and Malio do. They, I think, in a way, have an advantage, which is that as consultants, they get business clients who are ready to do something. And a lot of times when you're in-house, there can be some inertia around inserting predictive analytics into existing business processes that needs to be overcome. And so if you're very early in your journey, I think there's a certain amount of sort of put up or shut up and sort of proving what you're capable of doing. And so my advice to sort of deal with that is it may make more sense to start modestly. And that doesn't mean that don't have the goal of taking on big projects, or that your project might not end up being big, but that you may decide that I need to show some results before I'm going to get someone to commit to inserting my model into their business process. And that can be really important. So if you have, as federal agencies, we're often very good at having a lot of historical data. For our administrative data, we're very good at capturing that kind of thing. If you can get your hands on some historical data set and say, okay, if I had implemented this process 2 years ago and train it up and then score it against current day data and say, if we had implemented this 2 years ago, this is how much money we would have saved the agency. This is how we would have improved this key performance indicator by implementing our algorithm. Then it's a lot easier to get traction, when those numbers are big, for saying, okay, it's worth spending some smaller amount of money to insert this into a business process, which may be a significant IT investment. It may involve, sort of getting multiple contractors wrangled in a line. We've certainly found that with some of our operational models. But doing something like that, as opposed to saying, okay, it's easy to do sort of a forecasting model and, oh, my forecast was correct. I think you get both a faster timeline to be able to show some results, which I think a lot of people can become very impatient. And also that it allows you to say, this is a place where we could have an operational impact to improve it. So, Shakib gave an example of doing, maintenance predictions. which is very similar in a way to sort of doing default prediction, right? You know, Shakib is trying to predict the failure of a component, and we're trying to predict basically the failure of a loan. So being able to come in and say, we would have this sort of data, and if we used this data in this way, we could improve this outcome, is very valuable. And sometimes agencies have levers that they're able to pull, like statutory or regulatory authority, that they can take action. Sometimes you don't. And so then it becomes an even bigger issue of saying, if we had the regulatory or statutory authority to take this action based on our analytics, we could do the following. And then you get with your, you know, Office of Legislative and Congressional Affairs or wherever to make that change. But you can show without making the change that the change would be helpful. I think that's really important to sort of getting buy-in for this before you say, okay, I need to go out and spend multiple millions of dollars to hire data scientists, build a whole data infrastructure and deployment. It can be daunting.
Yeah, at Cognilytica, we always say start small, think big, iterate often, so that you have the larger picture in mind, but you're starting with these small little projects and chunks so that you can show results. Because I think that's, at the end of the day, people don't want you to be spending 1 year on a project and then not have anything to show for it. So that's definitely great advice. Now, COVID and the recent pandemic has definitely changed a lot. So all of us are now working from home rather than being in person for this event. We're doing it on the web. How has data and data analytics, how is that helping with the overall mission right now for a lot of agencies during the pandemic? And how does this factor into strategic planning going forward? Malio, let's start with you.
So kind of go what Shaki said a little bit, and I'm trying to reiterate. Predictive analytics can help is in the healthcare industry. It's in defense now, and now it's cheaper to analyze it. So now you have cloud computing, you have big data and IoT, which is kind of that fast data, high volume type of data. Well, say for instance, if you have 1 to 2 million messages per minute or per second, you can utilize that. And it helps with decision making. And the way predictive analytics helps out can help reduce your overall expenses year over year. We've on average using different models, whether it's timing series or whether it's anomaly series or whether it's kind of forecasting series, they average around 35 to 36%, depending on how what models they use and what they use the models for. You have to understand that you have to build the tools that fit the client or fit the person or fit whoever is in the workforce. So starting like Michael said, starting small and then working it big is probably one of the biggest things.
Okay, great. And audience, I just want to remind you, if you do have any questions, please type them in the chat and then we'll make sure to get to them. Otherwise, I have a lot of questions for the panel, so we'll run the full hour. But I would like to get your questions answered and asked to the panelists as well. But going back to this question, Michael, do you want to take it next?
Sure. So one thing, I sort of ducked the topic du jour on the last question, and Malio and Shakib were talking about data governance and infrastructure for capturing data, and now I'm going to actually circle back to that, which is that when you do have a infrastructure that you've built for data governance and having the capability to obtain data for analytics, that has some side benefits too, which is that you're now capable of very agile data analysis when things change quickly. And so we've certainly leveraged our enterprise data warehouse that we use for a lot of predictive analytics just for routine reporting on a weekly or even daily basis as to see what the effects of COVID have been on some of our business processes. And so there are a lot of sort of side benefits to having that sort of infrastructure. And I know that that's not a way of getting projects funded, saying, oh, well, there's this other benefit on the side. But it can be really helpful, and you can be really sort of a hero and save the day when the unexpected happens. One of the things I would caution folks about, and we're struggling about this on a project that I'm working on right now, I've been working on for quite some time, is how reliable are my models when there are shocks to the system like COVID. So models that I built and trained on data from a year ago or more may not be reliable in the era of COVID because they just, the models haven't seen what this looks like. And it may be very difficult to obtain an adequate amount of training data. We work on, pretty much annual cycles, and I think a lot of, other federal agencies do the same. Some don't. But being able to turn data around very quickly may be a challenge. So that's something to look at. And now you're back at relying on professional expertise, and that's never going to go away when things like this happen. Well, what do we think is going to happen? What did this look most closely like? So, we looked at some of the data that we had from Hurricane Katrina and saying, well, is this going to look like a national Hurricane Katrina where people are displaced or locked in their homes? There's all of this, or does this look like the Great Recession, right? Is this a macroeconomic event or a combination of both? And my fellow econometric forecasters like to talk a lot about that. But the best thing we can do is we can say, okay, here's the data and whether or not that supports that. So I think in the era of COVID, predictive analytics has a lot to offer, especially since this national event has, I think, gone longer than a lot of folks thought it would be when we first got into this in the spring. And we have the opportunity to use our tools to improve people's lives at a time when they really need that kind of help.
Great. And Shakib, you want to share your thoughts?
Well, I think Michael said it all. I think, like he said, the key is the data infrastructure. So the pandemic showed that actually how important data is. So it's something that it was unexpected, and then all the agencies were trying to rush to try to figure out what's going on, and so it's not only the infrastructure for you to collect your own data, the internal data, but also to incorporate external data from third parties. We saw a lot of organizations, universities and research centers and private sector also involved in collecting the data and providing that information as an open source, which was great to help everyone to work on this pandemic that was worldwide. So it was a common enemy for the whole world. But we were, federal agencies were a little bit behind in getting that because, we're still working on modernizing the infrastructure in making sure that we have the proper data pipeline from the acquiring data, from cleaning the data, from setting up the government's policies on that data, securing it, and then processing it and processing it and disseminate it. All of those aspects have to be in place for federal agencies to accomplish mission outcomes, especially when we have unusual situation like COVID. The silver lining there is that actually the pandemic has dramatically accelerated digital transformation in public sector. So there is definitely now, an awareness that it's very important to have the digital technology and the data and the critical infrastructure to enable agencies to be resilient and continue their work to accomplish mission. And that's something that we're going to see hopefully in the next years, a movement to actually have those agencies build the infrastructure that will help them sustain whatever was predicted or something that was unpredicted.
Yeah, that's great. Data has been a theme in your answers for all of these questions, and that's because it plays such an important part and an important role in predictive analytics. So what are, the big data challenges, and how is AI and predictive analytics helping to address these challenges? Shakib, let's start with you again.
Well, let me talk about it from the federal agency's point of view. I think the U.S. federal data strategy is central to the vision for modernizing the federal government and driving the data innovation towards enabling federal agencies to deliver mission outcomes, increase effectiveness, provide excellent service on behalf of the American people. So currently, all agencies, including NTIS, we are actually implementing the 2020 action plan, where we have action to be taken by all agencies, and those are going to help establish a solid foundation that will support the implementation of the data strategy over the next decade. So this is a central component in promoting predictive analytics and the adoption of artificial intelligence in general within the federal public sector. So this can definitely help federal agencies in their path, because there is the guidelines are there, and there is a strong collaboration between federal agencies. Now that we have CDOs in place, there is a CDO council that also can provide a general sharing of lessons learned and guidelines and etc. that can help in that process. There's a lot of organizations like ATARC and others that are also there are forums for collaboration between the private sector, from the public sector and academia, etc., in order to advance the AI knowledge and implementation within the federal government. But in general, if you want to look at the 5 areas that federal agencies should pursue for sure, is number 1, modernize the infrastructure, move away from legacy systems to cloud, or at least a hybrid architecture. Try to look at the data, as I mentioned, the data infrastructure throughout the data life cycle. Make sure that you're able to have to be able to collect data, to pre-process it, process it, and disseminate it. Hire data scientists. Workforce skills are important as part of that process. And also, we need to, and that's part of the action plan 2020, we need to enhance the data culture that is part of the agencies, because AI and predictive analytics are really transformative processes, and that means that they require a full transformation of how the organization works. So you need stakeholders, you need champions within the agency to help you with that process. And the best way to do it is to start with the problem. Like you said, Kathleen, start small. Yeah, look at the specific problem that you wanna solve, and then create a proof of concept or a proof of value there. That's what we do at NTIS. We have a very innovative framework. We start with a problem, and then we work in a very agile framework to try to come up with a prototype that try to address the problem. And then if we fail small, and then like you said, we iterate. So we don't want to have spend too much time and money and funding and then fail at the end. You want to fail early and small. And then, like Mario mentioned as well, another aspect that I will advise agencies to look at is at the ethical framework, because when you develop an AI solution, you have to look at the impact of what you are trying to accomplish on the American people. So as we rely more and more on AI, we need to make sure that we trust and we have enough confidence into the solution that we're developing with AI.
Great. Malio, you want to share your thoughts?
Yeah, some of the challenges I've seen in working with some of the agencies, local, even commercial clients, we kind of touched on the modeling, like whether it was class state, forecast, anomaly, cluster, or timing. but you also have to look at the algorithms also, and look at the subsets of those algorithms. So predictive algorithms should be a low error possibilities, whether you're boosting, which is kind of like a basic classic of how you cluster data sets, or you're banging it, whether you're taking subsets, whether it's training random or unclassified random subsets, and taking that algorithm and bringing it back together. So on top of the algorithms, the modeling, algorithms is probably one of the biggest things that creates accuracy. Starting small, running efficiencies, running certain values and biases, whether it's through certain decision tree making or supply chain management and things like that, can give you certain outcomes. And also, I also look at certain linear models when it comes to algorithms. So say for instance, if it goes 1 degree, you're a retail store and it goes 1 degree and you sell 300 coats in that retail store. Well, so if it goes 9 degrees, the logic is supposed to be that you're going to be selling 2,100 coats. Well, always not the case if you're labeling the subsets differently. So in a general linear model or for algorithm, you can get down to a granular level, whether if the subset is banging or boosting, and how your model comes out on the other end. So some of the challenges that I've seen some of the agencies, even when I worked in the agencies, is that you have to understand the model and the need behind what you're doing, and that kind of predicts the outcome. And like Shaki said, and like you said, Kathleen, start small. And Michael said, start small and get bigger, and then have that continuous training on those algorithms and those models to refine it.
Great. And Michael, do you have any thoughts on this?
So one thing, and I don't want to jump too far ahead, but Shakib mentioned about the human resources issue about this, about having the right people. And so there are a couple of things, and you can read on any number of sort of commentary websites about data science, about agencies or companies going and hiring a data scientist, and this is a very in-demand field right now. The salaries are very high, and then they misuse them. So because they didn't have their ducks in a row with regard to the data and in terms of getting their hands on it, you have data scientists who end up spending a considerable amount of their time doing sort of data wrangling and management work, which, number one, they're often not expert at. Number two, they're probably paid more than a professional who's really an expert at that would be paid. And then number three, they get frustrated because this is not what they want to do. This is not why they got into the field. And I certainly have encountered that in my work. So one of the things that you can do to, I think, empower your data scientist or data scientists is give them the right tools, not just in terms of the software and the servers that they're going to do all, but give them the right sort of supporting cast to help them work as a team with people who are experts on what they're experts on. So you need folks who are subject matter experts. You need folks who are experts on the data. And then you need folks who are experts on sort of data management, particularly in an era of big data. I know how to write SQL queries. I'm comfortable working in relational databases. It's a skill that I had to pick up. I don't know much about those sort of big data infrastructure. Hadoop is something I've heard of. So if I was going to work on that, I would need to learn about the algorithms like Malia was talking about that work well at that scale. And that I can learn. I've got the mathematical background. But I also need to learn about how to manage data at that scale, or better, because that's not really what I'm interested in. We need someone who's capable of managing data at that scale, who can work with me to help me do it, to make queries run efficiently. And I mean, it can be in orders of magnitudes in difference in performance. And I don't know how to make those things sort of work. So I think that there's a big issue when you scale up to sort of big data. And when I say big data, I mean data that's so big that it doesn't fit in a database anymore. That you need to go out to, you know, object store or distributed platforms like Hadoop and Spark. That those require specialized tools that do not work on data sets that are small enough to fit in the memory of a large server or in a database. And you need to have specialized people with specialized skill to handle those specialized problems.
Yeah, that's great that you bring that up, because I think that sometimes, especially maybe small groups, try and find this unicorn that can do it all, and that unicorn most likely doesn't exist. And then you're going to frustrate many people within the organization. So you're not going to be, you know, utilizing skill sets to their best ability, and then will potentially, you know, lose people as a result of that. So that's a really great point to bring up. My next question is about the financial sector. So this may be directed a little bit more towards Malio and Michael. But, you know, how is the financial sector using predictive analytics? And Malio, we'll start with you. I know that you have something that you'd like to bring up. So maybe Kirsten can put the slides on the screen at this point.
Sure. So this is kind of a little overview of what we've seen in predictive analytics, and when we're looking at whether it's the VA looking at homelessness, or the, you know, we help predictive analytics, how we help Japan, you know, predict floods and floodplains and flood zones and things like that. So there's a broad way of looking at predictive analytics. You can use this, and it kind of goes in stages, whether it's the data, intelligence, and then the action. So in the data set, whether it's your data source, your application, and your sensors and devices. So you can go on to the next slide, Kirsten. So this is kind of like a generalization of kind of how some of the devices and how predictive analytics work. When you start from the information management, you know, side of it, whether it's data factory, data categorizing, and huddles. You kind of go into the big data stores where, you know, Michael and Shakira and Kathleen yourself, you looked at data lakes, SQL data warehouses. You know, Microsoft has, you know, big data, you know, databases and things like that. And then you kind of go into the intelligence with the machine learning analytics tools like machine learning, data lake analytics, stream analytics, you know, they call them Spark or Hub and Drop. They're kind of machine learning analytics. And then you kind of get into the action piece of it, which is the intelligence of it, whether it's bot framework or cognitive services or power board and visualization and boards and stuff like that. So you can kind of go to the next one. So when you're talking about data analytics, you have to look at the end user, the matrix, and it's kind of establish governances when you're talking about in parameters, when you're talking about data analytics. Whether it's like what Shaki said, we're doing white papers around governance. What is technology do you consider? Whether it's machine learning, NLP, computer visualization, and things like that, which gives you the outcome. You can go on to the next one. So predictive analytics kind of goes into, like I said, into a few things. We're trying to get down what's the confidence interval of your predictive analytics. What gives you the lowest error rate when it comes to whether you're Z-testing, what model or what algorithm gives you the less, you know, gives you the highest confidence intervals on your, and what models give you the less error rates. So this is kind of things we look at, and when we're talking about whether it's alpha, gamma, or different subsets within in your data. You go on to the next one. This is also another one we use for anomaly forecasting, and also use called K-means algorithm. K-means means unlabeling your subsets And then the anomalies gives you a better confidence interval in some of our clients when we try to predict. In Canada, we try to predict some of the logistics, supply chain management risk models for REI. So things like that is what we looked at when we're talking about predictive analytics from a higher, from a 5,000 foot level point of view. That's all I have.
Great. I know that this question was focused specifically on financial sector. So Michael, do you have anything that you'd like to add to that?
So, federal student aid, we're a bank, but we're also a federal agency. And, we have a lot of business processes that are very similar to banks. And we also have some business processes that are quite different from banks. For example, we don't do underwriting on most of our student loans because they're an entitlement program. But that having been said, the financial institutions have very mature capabilities around a lot of predictive analytics, right? So, they look at credit scoring and doing a lot of what-if analysis. We are uses of predictive analytics to deliver directly to our customers. So we have a loan simulator on our website that a borrower can log on to and do some what-if analysis and say, what happens if I change my payment plan? How long will I be in repayment? What happens if I borrow more money? Sort of talking about, helping them make financial decisions around their student loans. So that's a sort of simple set of predictive analytics tools that we make available directly to our customers to help improve their financial empowerment. And that's a very big issue for us. In terms of our internal business processes, I think I mentioned some of them a little earlier about things that we do. We also are using some advanced analytics to look internally at forecasting. So Shakib mentioned about forecasting. We're looking at, what's our portfolio actually worth? How much money are we going to get back from that based on a variety of macroeconomic factors, various loan forgiveness and cancellation programs, what interest rates do, so we can do a lot of testing of that. And for those who are in federal agencies, a lot of times, a lot of your official reporting is bound by, federal standards around things like FICRA. And we're bound by those same sorts of things too. And sometimes that can be seen as an impediment to more advanced modeling. But there's nothing that prevents your agency from doing internal modeling that's more advanced. At FSA, we don't set up our own budget for the loan program. So we have a budget service, the Department of Education, that maintains a very sophisticated model that they use to evaluate it. But we also have our own models that make somewhat different assumptions. And so I think that, being able to do a lot of more sophisticated modeling around what you think our outcomes are going to be and what your financial situation is going to be as you go forward, I think helps you predict what kinds of needs you're going to have over the medium to long term.
Great. This was such a great webinar. I know we could go on for longer, but we're pushing up at the 2 p.m. hour. And so I know that our time is up. So I want to thank everybody who's watching this live. And if you're watching it on replay as well, thank you. If you're interested in participating in this HARC working group, please reach out to Kirsten. I know that we had a few people who messaged us about that already. So we're super excited to have you join us at our next event. Our next event, I'm sure we'll run some more webinars, but then also being a part of the working group. And I want to thank everybody on the panel today. You all did such an incredible job. So thank you for spending the hour with me.
Our pleasure.
All right, bye everybody.